All right, section 11.4 today. Last time in class, we figured out how to take the derivative of a vector valued function and then to use that to find the equation of a tangent line to a curve. All right, so here I have a funky looking spiral curve. This one, if I project down onto the XY plane, kind of gives this neat little figure, and then we kind of stretch it out. And it's got a bunch of tangent vectors stuck to it. All right, those pink vectors, you can see those are tangent vectors. These are actually unit tangent vectors. And by that, we mean tangent vectors that have a length of 1. And this unit tangent vector is going to be important for lots of different things. So let's figure out how to find these unit tangent vectors. All right, conceptually, these are very easy, right? We just take a tangent vector by finding r prime of t. We did that last time. And we make it a unit tangent vector by dividing by the magnitude of the vector. All right, what's difficult about this is that magnitude bit down at the bottom. R prime of t, depending on what kinds of functions you've got in r of t, that magnitude with that square root, remember magnitudes always have those big square roots, those can be very complicated looking. So not many of these are going to turn out to be pretty, but the concept is relatively easy. All right, I mentioned that not many of these are going to be pretty functions, but this one is going to be one of the ones that's not too bad. All right, so let's see if we can calculate that unit tangent vector function and then find two specific unit tangent vectors. All right, so I've got the formula down there on the bottom right for the unit tangent vector function. All right, so for t of t, big T vector of little t parameter, we take r prime of t on top. So we're going to take the derivative of r component-wise. So derivative of 3 cosine t is negative 3 sine t. Y component derivative, derivative of 3 sine t is 3 cosine t. Derivative of 4t is just 4. And then we're going to divide by the magnitude of that. Okay, so I'm going to take the magnitude of what I got on top. It's going to be a very big square root. I'm going to expand it as we go. All right, so I'm going to take negative 3 sine t, square it, 3 cosine t, square it, and 4 squared. And then make sure all of that lives underneath the radical and that you're adding between those squares. All right, so the top is largely done. Let's see what we get from the bottom. So I'm going to copy over negative 3 sine t, 3 cosine t, comma 4. All right, on bottom, big square root, I get 9 sine squared plus 9 cosine squared t plus 16. All right, and you're probably seeing it already why this one's going to turn out to be nice, because we got the sine squared plus the cosine squared with the same coefficient, which we can factor out. Okay, so I'm going to save myself a little bit of writing here and say, okay, so this is 9 factored out of sine squared plus cosine squared. All right, and we know that that's just 9 times 1. So this one's nice because underneath this radical, I just get 9 plus 16. All right, so we've got negative 3 sine t, 3 cosine t, comma 4, divided by root 9 plus 16, okay, which conveniently is equal to 25 underneath the radical. So it's just a 5 down in the denominator. So that's simplified beautifully. All right, so we've just got a 5 to divide each one of those components by. All right, so our vector valued function for the unit tangent is going to be negative 3/5 sine t. So I'm just dividing all the components by that 5 from the square root of 25. 3/5 cosine t, comma 4/5. All right, so that's our vector valued unit tangent function. And then they asked us to go ahead and evaluate t of 0 and t of pi over 2. So t of 0, let's see, sine of 0 is 0. So my first component when I plug in 0 is going to be 0. Cosine of 0 is equal to 1. So I'm going to get 3/5 times 1. And 4/5 is 4/5 no matter which way you, there's nothing to plug in, right? So that's our first tangent vector, unit tangent vector. And then also we were asked to find t of pi over 2. All right, so this time sine of pi over 2 is equal to 1. So I'm going to have negative 3/5 times 1. Cosine of pi over 2 is 0. So we're going to have 3/5 times 0. And then that last component, 4/5, there's nothing to plug into. There's no t. So that's just going to be 4/5. All right, and if we were to take these over to GeoGebra and to graph the curve and to graph these two tangent vectors, we would find they were just like those little pink arrows stuck to that curve. They look like unit tangent vectors.